Hi everyone, we are on level 3 now. There will be 2 videos for the level 3, and we're going to start off with something that we kind of learned before. We are going to rewrite the following equations into slope-intercept form. Right now these equations are in point-slope form, and we actually have learned how to rewrite an equation in slope-intercept form. All you do is you solve for y, you isolate y. And when we're in point slope form, we will need to distribute. So I'm going to first distribute the 3 in. So I have a 3x minus a 6. And then I'm going to add 1 to both sides to get a y is equal to a 3x minus a 5. Sorry, not a 7. And that's it. That's all they want you to do for these problems. They want you to just rewrite it in slope-intercept form. So same with number 2, it's in point-slope form. So to get it into slope-intercept form, I'm first going to distribute. And now I'm going to add 4 to both sides. And then number 3, I'm going to distribute. And now I'm going to subtract 5 from both sides. And that's it. All right, so we have talked about slope-intercept form, which is in the form of y is equal to mx plus b. We've talked about point-slope form, which is in the form of y minus y1 is equal to m times x minus x1. And now we're going to talk about one last form of a linear equation, and that is standard form. So standard form is a type of linear equation. Standard form is not as useful to us as slope-intercept form is. Remember, slope-intercept form, in the equation, we can easily identify the slope and the y-intercept. And in point-slope form, we can easily identify the slope and a point that lies on our line. Now, standard form, you will not be able to identify the slope or a point that lies on our line. However, what standard form is used for is it's used for a future concept called systems of equations. And so we're going to learn in this unit, and then we'll apply it later. So standard form is in the form of a times x plus b times y is equal to c. However, there are rules. A, B, and C will be filled in with numbers. And these numbers must be integers, meaning that they cannot be decimals, they cannot be fractions. And now most of the time, in most situations, some people might say A needs to be positive and cannot be negative. Some other people might say that A can be negative. For us, we're just going to make A be positive. So A needs to be positive. All right. So, looking at number 4, right now this is in slope-intercept form. We need to get into standard form. So how we do that? All right, well, we can't have any fractions. So I need to get rid of my fractions fully. So I'm going to multiply by the denominator of the only fraction that I have, which is 2. And so I'm multiplying everything by 2 because I do not want to change the value of my equation. If I multiply every term by 2, I don't change the value. A 1/2 times a 2 is just a 1, so I'm left with an x here. All right, now you want to isolate your constant. So I'm going to subtract x from both sides. And in standard form, your x comes first. So I have a negative x plus a 2y is equal to an 8. And then a, which is your coefficient of x, must be positive, which in this case my coefficient of x is not positive. So I need to make it positive by multiplying every single term by -1. This is now in standard form. So number 5, I don't have any fractions, so I don't have to worry about multiplying everything by something. I'm going to start with distributing. And my goal is to isolate my constant. So first I need to get my constant over to one side. And now I'm going to isolate the constant by subtracting 3x from both sides. And remember, your coefficient of x cannot be negative, so I need to multiply everything by -1. And now this is in standard form. All right, number 6, right now I have fractions, I need to get rid of them. So I need to multiply my entire equation by, since the denominator of the fractions are different, well, 2 times a 3 is a 6, so if I multiply this entire equation by 6, I will completely eliminate my fractions. So a 6 times a 2/3. I do the 6 times the 2, which is a 12, then I do divided by 3, which is a 4. And then a 6 times a 1/2, 6 times the 1 is a 6, divided by 2 is a 3. And now I need to isolate my constant. So I'm going to subtract 3y from both sides. And I have a 4x minus a 3y is equal to -3. And my coefficient of x is positive, so this is standard form. All right, so now we are going to write the equation of each of these lines in slope-intercept form for the following graphs. So slope-intercept form, remember, is in the form of y is equal to mx plus b. So you need your slope, you need your y-intercept. It's probably easiest to first identify the slope and the y-intercept and then write your equation. The easiest way to identify the y-intercept is just to see what point this crosses the y-axis, which in this case would be -4. So my b is -4. And now I need to pick 2 points on my graph. We've found slope from a graph before. Picking 2 points on my graph, it does not matter which 2 points. I'm going to do rise, which in this case would be 1, and run, which in this case would be -1. So my slope is a 1 over a -1, which is just a -1 slope. So now I have enough information to write my equation in slope-intercept form. It is y is equal to my slope, which is -1x, plus my y-intercept, well, plus a -4 is the same as -4. This is my equation. So looking at number 8, my y-intercept is 1. I'm going to pick 2 points on my graph. Well, I already have my y-intercept picked. Now let's pick another point. And I'm going to do rise, which in this case is 2, over my run, which in this case is -1. So my slope is 2 over a -1, which is a -2 slope. So my equation of my line in slope-intercept form would be y is equal to my slope times x plus my y-intercept. All right, and then the next one, my y-intercept is 4. Picking 2 points to find my slope, I go down 1, which would be -1, and over 2, which would be +2. So my slope is rise of -1 over a run of 2. My slope's -1/2. Writing my equation in slope-intercept form, I would have y is equal to my slope plus my y-intercept. And that is it. So that's writing your equation from your graph in slope-intercept form. Now we're going to look at the same 3 graphs, and we are going to write our equation of our line in point-slope form. So what you need to write an equation in point-slope form is you need your slope, which we found all the slopes above, because these are the same exact graphs, and you need a point on your line. So your choice, what point you want to use, it does not matter. For example, maybe you want to use this point here, which is the point -3, -1. If you chose that point, then your equation would be y minus the y value of that point, which would be a -1. Y minus a -1 is really a +1, is equal to your slope, which we found up here to be -1, times x minus the x value of the point that you chose, which in this case, x minus a -3 would be a +3. So there's actually an infinite amount of choices or equations that you can write for numbers 10 through 12. For example, maybe you chose this point here, which is the point 1, -5. If you chose that point, your equation would be different. It would look like this. Y minus the y value of the point that you chose, which y minus a -5 would really be a y plus a 5, times your slope, which was -1, times x minus the x value of the point that you chose. Now, I'm not requiring you to have multiple equations, but I wanted you to see that both of these equations look very different, but they both are correct. All right, so I'm just going to give you an example for number 11. Maybe you want to go with this point here, which is the point 1, -1. So your equation would look like this. Y minus the y value of that point, y minus a -1 is really a +1, is equal to your slope, which we found up here to be -2, times x minus x1, the x value of this point. Again, your equation could have been different depending on the point that you chose on your graph. And number 12, maybe you want to use this point here, which is the point 0, 4. If you chose that point for number 12, your equation would be y minus the y value of that point, which is 4, is equal to your slope, which we found above to be -1/2, times x minus the x value of this point that you chose, which is 0. Again, there are an infinite amount of equations that would work for numbers 10 through 12, but those are just a few examples. All right, you need to continue to the next video.